Hello, everyone. So today we are going to talk about force of interest. So far, we talk about interest and then discount. And now we are going to talk about force of interest. So the idea behind this concept is actually continuous. We want to credit interest continuously. So when we want to do that, how we define rate. So for when you have compound interest or simple interest, you have rate I. For example, if it's compound interest, you use the formula 1 plus I to the power t, given some present value. So this would be the future value. And then if you have simple interest rate model, then you define future value to be present value time 1 plus I to the t. Discount, again, you have formula. So in here, the I, this is annual rate, effective rate per year, per month, depending on the time frame you are using. So now we want to expand that idea and we want to discuss how to price or how to calculate interest for instrument which credit interest continuously. Okay. So here is the idea: continuous interest and force of interest. Okay. So financial transactions occur at discrete time points. However, many mathematical models are built on assumption that transaction occurs continuously. We can develop continuous model by taking limit on discrete process. So we are going to take a limit on discrete process. So here you can see the accumulation function AT, and we are defining a force of interest. So if you look at this, the way it define a limit, m goes to 0, you have the accumulation function. Then divide by AT. So this is basically, if you look at the, if you look at this one, this is same as you are taking the derivative. A prime t over AT, which is going to be basically derivative of log AT. Okay. So this quantity is called as force of interest. Okay. Um, so um, so this quantity we are going to use to calculate interest on continuous model. So when you see here the word money grows at R% compounded continuously, that means delta is basically equal to R%. So now we can calculate the force of interest under a different model based on that formula. So if you look at this one using this formula, or you can use this one to calculate force of interest under different model. So if I have simple interest, then I know that my accumulation function is going to be 1 plus IT. So A prime t is going to be I, and then you can see delta t is going to be A prime t over AT, which is I over 1 plus IT. If I take the compound interest rate model, then AT is going to be 1 plus I to the power t. A prime t is going to be then the derivative. So you have to take the derivative of this one, log 1 plus I times 1 plus I to the t. And then if you take the quotient, this would end as log 1 plus I. So so that's so here you can see then 1 plus I is going to be e to the delta t. Okay, so that's a nice fact. So when you see the model like in compound illustrated model, present value term 1 plus I to the t, you can replace 1 plus I by using this one. So you can get another expression. Then the simple discount rate at D. Again, you can write the formula AT using simple rate D. It's 1 minus dt. You can derive the formula for delta T using this formula. So here you can see a few facts. Effective discount rate is less than the nominal discount rate, which is less than cost of interest, which is less than nominal interest rate, which is less than effective interest rate. So this is effective discount. This is nominal discount. This is cost of interest. This is nominal interest. And this is effective interest. You can try to prove that. Try to prove this fact, whether it is possible or not. See whether you can do it. For example, we know that 1 plus I equal what? 1 plus I to the power m over m to the m. Okay, so m is so from here you can solve for im, which is going to be what? 1 plus I to the 1 over m minus 1 times m, which is im. So now somehow you need to argue that im is less than I. Okay. So see whether you can prove this. It would be a nice exercise. So here you can see a formula which you can use to calculate accumulation value. So it's AT equal e to the power 0t delta R dr. This one is coming from that expression. Delta T is A prime T over AT, which is log AT. So you can see that right away. If you integrate both sides, you would get this expression. So if T goes from 0 to T, so you can write delta R is you can integrate both sides, and then you can get the this expression. Okay, so when you integrate this one, what you get? So this side is going to be log AT minus log A0, which is 1. So this entire thing becomes 0. So then you end up AT equal e to the power 0 to T delta R dm. So you can really prove that. So in here you can see for compound interest, delta T is limit m goes to infinity im. That's another way to prove the another way to define delta T. So if you look at this, what's log 1 plus I? So if I take log of that, so that would be log 1 plus I m over m to the m, and then you are sending m to infinity. Okay, so this become constant. So this is become e to the power delta. So so that's the idea. So you can see that this is basically e. And then here you have discount factor. When you have constant compound interest, you can define, you can prove that cost of interest is constant, which is delta, and you will get this expression. So here we can see a few examples. If interest compound continuously, what will be the balance after 5 years of initial deposit of 5,000? So you can calculate right away. Future value is percent value time e to the 0 to 0 to 5 delta t dt. By the way, in this problem, you don't have delta t. So you have to use, let's use 0.05. So then this would be 5,000 e to the 0 to 5, 0.05 delta t, which is going to be 5,000, 0.05 to t, 0 to 5, and then you can get the answer. You are given I12 is 0.09, calculate delta. So we know that log 1 plus I equal delta, and 1 plus I equal 1 plus I m over m to the m. So you have two equations which you can use to solve this. So basically log 1 plus I 12 over 12 to the 12 equal delta. Okay, so I 12 is given here 0.09. Your investment and interest at constant cost of interest of 4%, calculate the monthly effective interest rate. So you need to calculate I12, divide by 12. So what's the monthly effective rate? If nominal rate is I12, then the effective 4-month is going to be what? You remember correctly, the definition is going to be I12 over 12. Okay. This is effective per month. This is nominal per year. So this is going to be the log of this is going to be 0.04, which is delta. So now you are solving for I12. So basically 1 plus from here. I told you earlier, so that's what you need effective one. So you need this quantity. So here we can see a question from exam FM. At time 0, 1 is deposited into each of fund X and fund Y. Fund X accumulated cost of interest delta t square over k. Fund Y equivalent nominal. At time t equal to 5, the equivalent value of fund Y X equal to the equivalent value of fund Y, determine k. So let's try to do this problem. So we have fund X. So at time 0, $1 is deposit, 1 is deposit. So, and then time t equal 5, and then force of interest. So, so x equal what? E to the delta t. Remember 0 to 5 delta t dt. And actually here I have $1. So the function actually x equal percent value time e to the 0 to t delta r dr. So in this case, percent value is 1, 0 to 5. Delta is given as t square over k dt. So you can solve this. If I solve the integral, it's going to be t cube over 3k from 0 to 5. So it's going to be e 5 to the 3 over 3k, which is 125 divided by 3k. So that's the current value, future value. Next, fund Y at nominal rate of discount at 8%. So per annum convertible semi-annual. So I have D4, which is 0.08. So I need to know the effective interest rate. If you remember 1 plus I, 1 minus T4 over 4 to the 4 is 1. Remember that equation? So I can get 1 plus I, 1 minus 0.08 over 4 to the 4 is 1. From here, I can get 1 plus I. And once I know 1 plus I can calculate the future value. Future value is percent value time 1 plus I to the 5, which is 1 time. So here you need to get the 1 plus I. Okay, so now you have two equations. This is 1, this is 2. And actually this part you know from the formula. So you can equalize that and solve for K. Okay, so I will leave the other problems for you to do. And by the way, here inflation, please read that one. The idea of inflation is when there's inflation, the real rate is going to be less than what is quoted. So this is how you calculate the real rate of interest. You take the 1 plus current rate, let's say J, and then 1 plus I, which is inflation. Then you subtract 1. This would give you the I real. I mean the J real. Okay, so this J is current. Okay. So under inflation, everyone know that the real value of the money is going to be depreciated. Okay, so for example, 2 years ago, let's say you can buy a house at 300,000, and now because of inflation, you cannot buy the same house at 300,000. Maybe you need to now spend 500,000. Okay, it's the same house. Okay, so what happened was inflation. So inflation depreciate the money value. So here you can find some articles and please read those about when the inflation goes really high, it become big problem. For example, in Germany and in Argentina and Zimbabwe, this happened. So hyperinflation is a big problem for any country. Okay, so that's the end of this module. We will meet again for annuities next time.